When network performance lags, many network professionals tend to forget about the basics. They ignore the vital importance of the domain name system, DNS, in speeding traffic and ensuring uptime. The first thing they should determine, though, is whether or not their DNS performance is optimized. But how can you tell whether your DNS is performing as well as it should? Unfortunately, comprehensive and precise data on DNS performance can be hard to find, mainly due to the complexity of such measurement. However, in a moment, we'll hear about a study based on a new testing methodology that can tell you exactly what's going on with your DNS. Hi, I'm Stan Gibson, and I'll be your host and moderator for this webinar sponsored by IBM and brought to you by BizTech Insights. Joining me to take a look under the covers of DNS and learn how to gain optimal DNS performance are three experts. Terry Bernstein, IBM NS1 Connect Product Manager. Welcome, Terry. It's great to have you here for this webinar. And could you tell us just a bit about NS1?
Yeah, it's great to be here too with everybody to talk about this topic, which is near and dear to my heart. NS1 Connect is a premium authoritative DNS service that offers advanced traffic steering to deliver the high performance and secure network connectivity that businesses need to meet their sophisticated needs. Most of our customers find speed is really important, so I'm excited to share with the audience what we've learned through this study.
Well, we're looking forward to it also, Terry. Also with us, Mark Towler, Product Marketing Director at Catchpoint. Welcome, Mark, and glad you could be with us today. And could you tell us just a bit about Catchpoint?
Thank you very much, Stan. Happy to be here. And certainly, Catchpoint is the industry-leading internet performance monitoring solution. What we do is we help our customers maintain and achieve internet resilience by monitoring from where it matters at their end users. And it's that ability that has really helped us with this partnership with NS1, our ability to monitor from where our users are all the way through the network. So we're very enthusiastic about this ebook and about this project.
Sounds good, Mark. Also with us from Catchpoint is Madan Gopal, Value Engineer. Welcome, Madan. It's great to have you here for today's webinar.
Thank you, Stan. It's a pleasure to be here.
Before we dive into our discussion with these experts, just a quick word to you and our audience. As our discussion progresses, we invite you to send us your questions. Just type your question into the Q&A box on your screen and hit the submit button. We'll answer questions during the Q&A segment, and if we're unable to answer your question, you will receive an email reply within just a few days. Terry, Mark, and Madan, just to begin, how does DNS performance affect application performance?
I think the other two are going to give you a much more technical response. So I'm going to take a step back and deal with it kind of from the end user and the user experience viewpoint. Basically, the internet is big, it's complicated, it consists of 1 billion different interconnected pieces that are all talking, and every one of those connections is underlaid by DNS. So DNS is really at the root of all of this. And if your DNS isn't performant, your application isn't going to be performant. Put another way, if someone comes to your website and for whatever reason, one of the many millions of connections between them and your website is slow because of DNS, they're going to be sitting here waiting 5, 10, 20, 30 seconds for your web page to load. And realistically, they're not waiting 30 seconds, they're waiting 10 and they're going to a competitor. So DNS is absolutely the bottom line and it's absolutely critical. You can be sitting here looking for optimization options, but if you aren't considering DNS, you're moving deck chairs on the Titanic.
Yeah, I think that's a really great point. And what a lot of people don't realize is that DNS is used everywhere. Most people might think, hey, the web page has a couple DNS lookups. Who cares how long DNS takes? But in reality, if you look at complex web pages, like this one that we analyzed from CNN, you'll see that there are pages of DNS links, DNS lookups on the page, looking up all the advertisements on the page, all the videos, all the images, all the different pieces of the website. And even if each of those DNS lookups takes an extra 20, 30, 40 milliseconds, it adds up. And it ends up just slowing the web page down. I know when looking at web pages like this, DNS can take up to 30 to 50% of the total page load time. So it's really, really critical. If you want to have a fast website, you need to pay attention to the DNS.
Absolutely, Terry. That's an interesting image that you have on slide. I would like to also add uh, a very important metric, which is time to first byte, also called as TTFB, which is a critical factor in DNS performance. TTFB refers to the time it takes for a user's browser to receive the first byte from server after a request is made. Now, this metric is crucial because it directly affects the overall load time of a web page. At the same time, it affects your SEO scores as well, because search engines like Google, they consider DNS resolution speed while ranking your website. So slow DNS performance can negatively impact your site, at the same time your SEO ranking as well.
Yeah, no,
Look at
that's a great point. I'll just say a lot of that's why many of our customers, when they're evaluating DNS providers, they look at performance. They make sure that time to first byte can be made as quick as possible. The other thing I just want to tangentially share some experience from our customers is it's not just about the latency of the DNS, which we're going to talk about here today, but you can actually use the DNS to steer the traffic. That's a whole other webinar on its own, but it's a topic that's important to also the customers also think about in terms of getting the fastest time to first byte. That is, I have a big infrastructure. I have lots of servers around the world. I want to get to my customer to the server that will give them the fastest time to first byte. And so DNS can be used to make that initial choice with the global server load balancing technology. So yes, DNS latency is super important. We're going to talk about it a lot today, but DNS can also help choose the best server location, best cloud service, best CDN to minimize that time to first byte, thus leading to the fastest possible user experience.
Well, let's turn our attention to measuring DNS performance. What are some of the ways that DNS performance can be measured, and what are some of the challenges involved with that? Madan, maybe you'd like to take that one.
Sure, Stan. DNS performance can be measured through various methods. First of all, we have something called as real user monitoring, also called as RAM, and we have synthetic monitoring. Now, RAM captures data from actual users, providing insights into how real-world users are experiencing your DNS performance. On the other side, which is synthetic monitoring, it's tested more in a controlled environment, allowing for consistent and repeatable tests. It's more like simulating the end user experience. So we typically focus on metrics like response time, uptime, and consistency of the responses. Now, response time measures how quickly is your DNS server responding to a query, which is crucial for ensuring that users can access websites and applications swiftly. And challenges, yes, it comes with a lot of challenges, to be honest. Factors such as local ISP connections, geographic distances, routing inefficiencies, and also proximity of resolvers. All these factors affect your DNS performance. Now, simulating DNS response data in a controlled environment, it's a very important thing because all these factors can introduce noise and inconsistency when you're measuring something. Say a tool like Catchpoint, which can, we do have strategically placed nodes across the globe, which can provide you reliable and ideal lab environment to gather actionable data without adding these all different factors which I just spoke about.
Well,
I believe you're talking about our global observability network there, Madan. I just thought I'd throw it up on the screen.
Absolutely. So this is the global observability network that we have. So if you look at the screen, we almost have around 2,700 plus vantage points, nodes, probes, different organizations call it in different jargons or names. So using all these different nodes that we have, you can get accurate DNS measurements, excluding all those factors like end user noise or the proximity and all this stuff.
Madan, perhaps you could tell us exactly how Catchpoint measures DNS performance. Why is Catchpoint different?
Sure. Now, Catchpoint has different ways of measuring DNS performance, right? So we have variety of different tests, which suits for variety of different use cases. Now, firstly, let me start off with something called as a direct DNS test. Now, this involves querying authoritative DNS servers directly to gauge their efficiency in responding to the request. Now, this method provides a clear baseline of DNS server performance by isolating it from other factors. Next, we have something called as DNS experience test. Now, these tests are used to measure resolution accuracy, reliability, and geographic reach. Experience tests can also help you in understanding how your end user experience is affected, and also understand, the complexity of DNS resolutions, latency variations at different levels. And finally, we have something called as instant test. Now, this offers immediate insights into point-in-time DNS performance, allowing for quick diagnostics and troubleshooting. Just to mention, for this particular assessment, we went with direct test without leveraging any DNS accelerators. Instead, we allowed local resolvers to choose the best name servers autonomously. Now, this approach aligns more closely with what end users are experiencing, ensuring our measurements reflect real-world use case.
Yeah, I just want to add, I was really pleased to see the method that Catchpoint recommended. Having been in this industry a long time, I've learned to question the results from these kinds of tests because there's so many variables that can go into setting these up, and just the combination of the huge vantage points across all these cities and providers and is just really powerful. And then the flexibility to craft a test with Catchpoint's Madan's guidance that really allowed us to compare fairly all the different providers was just really great. We spent a lot of time with our engineers reviewing it, making sure we were all on the same page, and I think we came to a really, really great result.
Also, I would like to add another point, right? Sorry, Stan, right? So now, how is Catchpoint different, right? So now, what sets us apart is our commitment to measuring DNS performance from outside in perspective, right? So now, a lot of organizations, what they do is they try to attempt to monitor DNS performance within their organization or within their infrastructure. Now, this is called as inside-out strategy. Unfortunately, it fails because we cannot replicate the real-world scenario. Instead, we always emphasize an outside-in approach because always monitor from end users' perspective to have more accurate and actionable data. And the other thing, I'll give you an example. Let's say you have a cloud application which is hosted on cloud, and there are tools which provide probes or nodes which are deployed in a cloud location, right? So now, if you're trying to measure your DNS performance from the same cloud node where the cloud-based application is hosted, you don't have the true picture, right? So, because end of the day, end users does not originate from the cloud, right? So that's the reason why I'm stressing always monitor from where it really matters.
And honestly, this is one of the things we've seen just overall with Catchpoint, not just for DNS, but for any other type of monitoring. Everything can look green. It can look like everything's working perfectly. If you're sitting here in North America and you're less than 100 miles from your servers, clouds, data centers, whatever. Meanwhile, there's some poor guy in Dubai who's looking at a 5-minute load time. And that's where the value of this kind of expansive global observability network comes in. It allows us to see, at least from Dubai, whether or not there are any slowdowns in it, whether or not there are any issues, and give IT teams the knowledge so they can rectify those. If that's a slow CDN, they can switch. In some cases, we've been able to track issues right down to the fact that this user's having problems because their router is old and out of date. And if they swap out their router, problem solved. That's the sort of thing that's really hard to determine if you're sitting in the middle of your data center and go, well, it all looks good to me.
Interesting. Well, I'm wondering, what were some of the most interesting findings that you uncovered during this project? Maybe each of you could take a crack at that.
Sure. Honestly, and again, we could probably have a more technical answer from the other two, but what really surprised me was the level of variance between DNS providers. It's the sort of thing where it's kind of like, it's the internet, it's work that, there's going to be slight differences, but I don't expect it, I don't expect it to be a huge difference. And we were surprised. There were significant, and I'm not talking, a handful of milliseconds or 5 to 8% sort of differences. We're talking tens of percentage point differences between some of the faster and some of the slower providers. And that's not something you think about it and not something you expect. So I was talking earlier about, optimize your network. It doesn't really matter what DNS you're using. They're all kind of the same. It actually matters more than I thought.
Yeah, we were pleasantly surprised at that result, to be honest, where NS1 was clearly the fastest worldwide, and especially compared to self-hosted, which we intuitively makes sense. Self-hosted means a company has their own DNS infrastructure. Most companies that do this will have a few servers, maybe located in one region of the world. Whereas the premium providers, NS1 included, have worldwide infrastructure with lots of servers. I will say, too, I encourage everyone to download the report because we have more detailed information in there. For example, this is just the averages. We break out individual providers in there. You can see how everyone stacks up. And I was, again, pleasantly surprised NS1 was at the top. But it also depends on the region you're in and other factors. But definitely an eye-opening study.
Congratulations, Terry and NS1 team. With that, let me bring up the slide. All right. So another interesting finding was, the significant impact of geography on DNS performance. Right? This was very fascinating, to be honest. So we observed notable differences in DNS performance across regions like North America, EMEA, and Asia. For instance, DNS responses can vary greatly depending upon the density of DNS servers and the distance between users and these servers. Our data clearly showed that, the geographical location of users and DNS servers can dramatically affect DNS response time. So this chart, what we have here, if you look at the difference here, if you look at Oceania or South America versus Europe and North America, there is a huge difference. So just to give you a quick insight, the average DNS response globally was around 263 milliseconds, but this varied by region. Now, North America and Europe generally showed faster response times due to higher concentration of data centers, DNS servers, and closer proximity. On the other side, regions like Asia and Oceania, they faced longer response time due to greater distances and less server infrastructures. I would also like to mention another thing, which is China, right? So now China presents a unique challenge due to its regulatory controls and specific internet architecture, which results in slower DNS resolutions when accessing servers outside China. Now, Catchpoint hosts the largest number of nodes inside China, providing a comprehensive view of DNS performance within the country. However, in this report, we did not include China because, considering those unique challenges, as it would not be a fair comparison.
Yeah, and just to jump in there on that, I agree. China's a totally different beast. I know when we use Catchpoint to measure our worldwide infrastructure, and we carve out the tests from within China to be separate just because you've got that unique networking situation. But for tests within China, it's amazing. And we've actually built our own DNS network in China. Again, not covered in the test, but if you have business in China, definitely worth checking out because it provides those DNS queries and responses just right within China and avoiding those headaches of going across all the barriers between China and the rest of the world.
Very interesting. So what are the key takeaways for members of our audience today, Mark? Maybe you'd like to go first.
Oh, sure. This is kind of illustrating the point I made earlier where, I wasn't expecting these significant differences, and geography just makes it more obvious. You're looking at almost twice the delay for Oceania versus Europe. And if that's the case, that's something you've really got to pay attention to. And that's why it's really important to measure your DNS performance. Again, you're sitting in your data center, everything seems fine. You've got no insight into someone in Dubai or Tokyo or or Sydney or Taiwan, and they may be having a very, very different experience, and that can be crippling. They can explain why you're not getting the visitors to your website or to your product or your service or your application regions, and you're not going to have any clue if you're not measuring some DNS performance. And even if everything else looks great, bear in mind it all starts with DNS. So this variation in performance has a much bigger impact than we were originally anticipating, and I think that really brings up the one critical thing: measure it, because you've got no way of knowing otherwise.
Madan, what are the key takeaways?
Yeah, I mean, the key takeaway, it's pretty much straightforward. Start measuring your DNS performance, because it's crucial to understand how it impacts your overall network and application performance, which directly impacts your end user performance. So I encourage everyone to download the ebook from either NS1 or Catchpoint website. And the ebook contains detailed data and actionable insights that can help you improve your DNS performance. It provides a wealth of information that can guide you in making informed decisions about your DNS infrastructure.
Yeah, and listening to my colleagues here talk about the impact, I just want to go back and you can compare this slide. As you see, there's 100, it could be 200, 300 milliseconds difference between the different. And then if you look at this slide and just see the number of DNS lookups. So 200 milliseconds slower is not 200 milliseconds slower. It's 200 milliseconds times 20, which is 4 seconds, right? That's crazy. It just really brings it home to pull all this information together. So yeah, I think I'm really excited about the collaboration we did. It's great work, really focused effort to get a good, strong benchmark that makes sense, that's been technically vetted, and it can make a real difference, as you can see from the data we've shared.
That CNN diagram you brought up, I think when we took that, and again, CNN's literally changing day by day, hour by hour, that was, I want to say, 400 plus different calls just to paint the first page. And a lot of those are like video and a lot of other things with a lot of lag. It could be 600 on another day. It could be 300 on another day. And as you mentioned, it's not, there's a, 50 milliseconds delay. It's 50 milliseconds times potentially 400, which, obviously makes it unusable. So it really is more crucial than you think.
How can members of our audience get started with NS1 Connect or Catchpoint?
Honestly, the first way is to get in touch with us. If you'd like to measure your DNS performance or learn what else could be impacting your services, your websites, your solutions, whatever you're offering, get in touch with us. You can go to catchpoint.com. You can even email us at hello@catchpoint.com, and we'd be happy to help you figure out exactly what we can do for you and how we can save you a ton of money by making things faster and keeping your customers happier.
Yeah, and similar for NS1 Connect, we have the link here to our product page. On that product page, not only can you learn all about the product, but we have a free service available, so you can try out NS1 Connect at your own leisure. And if you want to get more into depth, we can set you up with a full trial with all the whiz-bang features enabled, so you can try it out and just see how great and how fast the experience is.
Great. It's now time for the Q&A segment of our webinar, and we have a number of interesting questions waiting for us. So let's begin. First question, how did you factor in DNS accelerators? That was mentioned, the accelerators, during the discussion. Were they factored in? And if so, how did you do that?
I think I can take that question, Stan. So in our study, we deliberately did not use DNS accelerators, right? So this is to ensure we capture baseline performance to reflect a typical end user experience. Because as a regular user, I don't configure Google's or Cloudflare's DNS on my machine or on my router unless I'm a tech savvy, right? So by allowing resolvers to choose the best name servers autonomously, we aim to simulate real world conditions without influence of acceleration technologies. So now this approach provides a more accurate assessment of DNS performance, and it would be experienced by, without any enhancements like using DNS accelerators.
All right, next question. Now, we've established that DNS is certainly important for network throughput and that NS1 Connect can boost performance. But can NS1 Connect also prevent downtime? And if so, can its ability to do that be measured?
Yeah, let me take that one. I think there's two parts to the answer. The first part is it prevents downtime by the DNS itself being always available. That's probably step one. DNS is behind every transaction. If DNS is down, then your website is down, your application is down. So NS1 Connect itself is highly available. We have 100% availability SLA on it. But many of our customers don't just want to trust us. They want to have another provider available. And so we support all the different methods within DNS to support multiple providers, which many of our larger customers take advantage of. So if the other vendor goes down or the unthinkable happens and something happens to NS1, then they're still protected. NS1 even has an option where we can stand up two completely separate DNS resolution infrastructures for a customer. So the point is lots of ways to make sure that a DNS service is always available. NS1 is super reliable, and then there's some ability to create backups as well. That's part one. Part two, in terms of reliability, is DNS isn't always the thing that fails, and hopefully it's not the thing that fails if you use NS1 Connect or one of the solutions we have. But other things will break. And I mentioned earlier global server load balancing. That's a really important technology to steer around other types of outages. So say that you're using multiple CDNs and one of your CDNs is having a bad day and their service is down in the Western United States. Well, if you're also using NS1 Connect, you could use our global server load balancing to steer around that CDN into the other CDN you have, which is still working. Or maybe it's your data centers. You have data centers in different parts of the world, and one of your data centers is having a bad day. You can use NS1 Connect to steer direct people to a different data center to get access to the application. So yeah, NS1 Connect is a really critical tool in many ways to ensure application and website availability.
All right, next question then. What should people do if they suspect that their performance isn't up to par, other than measure their performance with Catchpoint? What's an easy thing to do? Maybe move to a managed DNS provider versus more advanced steps, perhaps traffic steering, and as you mentioned, global server load balancing, GSLB.
I think the ones listed here in your question or that you brought up in your question are really probably the right things to do. And as I mentioned earlier, we have a trial service and a free service that someone can go to experience how much faster it would make the website, and then you can compare. I mean, one of the things that we've done is you could stand up put two different DNS entries, two different names in front of the same application, and then measure the difference using Catchpoint. So you could really get an A/B comparison. I don't know, maybe one of my Catchpoint colleagues could talk about how their customers do that sort of thing.
I was waiting for a chance to break in, honestly. No, I mean, I think the number one thing is, as you mentioned, Stan, measure it. And there are other tools out there. We obviously think Catchpoint's the best, if only because we get that measurement from where your user is, as opposed to others who don't do that. But the other thing I will mention, and that kind of reflects on all of this, is again, DNS is crucial. It's not always DNS, despite we were actually in a conference a couple of weeks ago and mentioned a DNS issue, and one of the analysts muttered, it's always DNS. It's not always DNS, but finding out whether it's DNS or something else is the biggest challenge, and that's kind of what Catchpoint's there to do. It's going to help you figure out where the problem is and reduce that mean time to identification so you can resolve it. Again, same thing Terry was talking about, if you need to move to a different NS1 server, Catchpoint can tell you that you need to do that, and you're not necessarily going to know otherwise. So I think that's critical. It's essential not only to be able to monitor and observe, but to know where your users are having problems and to have a plan for what to do. Classic example, if you're relying on one CDN and that CDN is not working, well, other than going, yeah, that's the problem. What are you going to do about it? NS1, you can reroute around DNS issues. If you've got multi-CDN, you can move around. There's lots of options for automation, even if you want to do something on this. But the first step to fixing anything is to figuring out what the issue is. And the number of times we have seen our customers prevent expensive war rooms where they're getting people with, six-figure salaries grouped into a virtual meeting for half an hour just to try and figure out, beyond the finger pointing, who's responsible. Is it network? Is it someone else? Where's the issue coming from? When we can go look at that screen, it tells you right now it's the CDN. Eliminates all of that, and that's usually where Catchpoint pays for itself. And especially with DNS, as we established, it's the core of everything. If we can identify that fast, you know what you can do about it.
We have time for one more question. Sorry. We have time for one more question, and the question pertains to cybersecurity. Now, there continue to be major DNS attacks. How can we protect ourselves from DNS-related malicious behavior?
Yeah, let me take the first shot at this. I think there's a couple of types of DNS attacks that using a professional managed DNS service like NS1 Connect can protect you from, as opposed to managing it on your own. The first is DDoS attacks, volumetric DDoS attacks against DNS. In those types of attacks, the malicious actor floods the service with an overwhelming amount of traffic, thus preventing the DNS from working, just like they might flood a website. And it's very hard to protect against, while also maintaining the service for the good traffic. And we found that most organizations that run their own DNS that are self-hosted have real trouble protecting themselves from DDoS attacks. So that's number one. Number two is use some of the advanced protocols like DNSSEC. They can help protect against spoofing. They can protect you if an attacker gets very sophisticated and starts changing network routing such that the DNS queries don't go to the server you expected them to. They go to a malicious actor server and provide incorrect answers that direct people to a malicious website. And so that's one area where using a service like NS1 Connect can really help, because we've made things like DNSSEC really easy. You essentially flip a switch, we sign all the records, and we can help you configure everything such that they continue to work operationally and have no downtime while turning that on. So yeah, those are a couple of things that I've thought about.
Just to add to that, Terry brought up a very important point there, DNSSEC. Make sure your DNS providers support DNSSEC. At the same time, we Catchpoint can help you monitor DNS certificates. So we have a separate test setup for that, where you can continuously monitoring if it's a valid DNSSEC certificate or not. And yeah, that's pretty much.
Well, it's certainly been fascinating information. That is all the time we have in this video webinar. Sincere thanks to our three experts, Terry Bernstein of IBM, and Mark Towler and Madan Gopal of Catchpoint. Thanks to all three for explaining the importance of DNS in today's networks and how IBM NS1 Connect can optimize DNS performance. If your question was not answered in the Q&A segment of this webinar, you will receive an email reply within just a few days. For more information on DNS and IBM NS1 Connect, including that new white paper, please click on the handouts icon on your screen. This webinar is copyright by IBM and BizTech Insights. The presenters are solely responsible for its content. I'm Stan Gibson, and thanks for attending.